apparent shift and normal shift due to refraction. When we saw the bottom of the water tank, it seems to be shallower. That is, the height of the bottom of the water tank seems to be raised from its level. Or when an object is kept, or a coin is kept at the bottom of the water tank, its height seems to be raised. This is due to the phenomenon called refraction. Apparent shift. Apparent shift. In a water tank, water is kept in this water tank, and we keep a this is the level of water surface. This is air, which is rarer medium, and whose refractive index is equal to mu A, which is equal to 1. This forms as the medium number 1. This is medium number 2, water. It is denser medium, and its refractive index of water is equal to refractive index of the second medium is equal to refractive mu. Now, a coin is kept at the bottom of the water tank. Then its image will be seen here when you look from this side. When it is looked from the air downwards, the rays will come from the eyes will see the object. If the rays are coming from the coin, it means from where the rays are coming out, from there the rays are coming, and it enters in this region. It enters this medium. It means where it is the ray seems to emerge out. That will be taken as the second medium, where after refraction, where it is entering, that medium will be taken as second medium. That will be taken as the first medium. So this is first medium, this is second medium, from where the light is going to the eyes. So this medium will be second medium. Now when an object is kept here, a ray from coin will reach the eye, which falls normally on the interface. We can call this is the interface, LM. So when it is falling down, so it will also follow undeviated, because the angle of incident, this is the normal and this is the incident ray. So angle between the normal and the incident ray is equal to 0, and angle of refraction also will be 0. Now we take one more ray like this from the object, which this is point A, this is which is incident on the interface. After refraction, it will undergo refraction. This is the normal at this point. Since it is going from denser medium to rarer medium, so the ray will bend away. Instead of like this, it will bend away like this, bend away from the normal. So this is the angle of incident of the ray from the denser medium, and this is angle of refraction for this medium, angle of refraction. Okay, now what about this angle? We say this is object. When we extend this ray backward, that point intersecting OA at I is the virtual image. I is the virtual image of this object. Why it is virtual image? image, because already in the previous video I said when the light ray seems to diverge from a point, appears to diverge from a point, that forms virtual image. So it means the object will be seen here when it is seen by the eyes from the air medium. So virtual image. So now what is this? This angle will be, this angle will be again I. Why? Because this is, we can call it as B. So at B, this is I, and this will be also I. That is at O, this is E. So again, this will be I. So this is I, and this will be R. Why? Because A, B, and it is extended image. This is I, this is E, and this is B. In that case, here also this is refracted ray, this is normal. If this is R, this will be also R. That's why this angle is equal to R. Now, this is the image of this object, that is coin, is produced, virtual image. So it means when seen from the top, it seems the object is raised through a height of, through this much of height. This is called normal shift. OI is called normal shift. That is how much height the object is raised. Therefore, OI we call it as normal shift. Okay, now AI, this is AI, this is A, this is I. This height up to where from here to here it is raised I. Oh, this is called apparent height, apparent depth of the object. So OI, AI, we call it H dash is equal to H dash is equal to apparent depth of object. Apparent depth means how much height the object is raised up. So that height is called apparent depth of the object. And AI is, we write is H dash, A is equal to H is equal to real depth of object, real depth of object. Both are from the water surface, both from the water surface. So the height is measured from the water surface. So this height is H dash, this height is H. So you can write AI is equal to, then now this triangle, let us take this triangle. We applying Snell's law at the interface. When Snell's law is applied at the interface at this point, it means this is denser medium, sine of I into refractive index of the second medium into sine of angle of incidence is equal to sine of this medium's refractive index and sine of angle of refraction into refractive index of the air medium. See, we can see mu1 into sine of R. So mu2 is equal to refractive index of water into sine I is equal to refractive index of air into sine R. We can write it as sine I by sine R. Sine I by sine R is equal to, sine I by sine R is equal to refractive index of air by refractive index of water is equal to refractive index of first medium by refractive index of second medium. So by paraxial approximation of angles angles. Tan theta, sin theta is approximately equal to theta. Sine of 9 degree is equal to 9 degree. Tan of theta is equal to theta. That we can say theta is equal to sin theta is equal to tan theta. This is applicable. The paraxial approximation is applicable for small angles, and all the rays are paraxial. Paraxial means it is all the rays are paraxial. So it means we can see theta is equal to sin theta, or theta is equal to tan theta. Since angle I and angle R are very small angles, angle I, angle of incidence and angle of refraction, angle of incidence and angle of refractions are very small. So we can apply paraxial approximation. That is, instead of sin theta, we can write, instead of sin I, we can write tan I, tan of I divided by tan of R is equal to refractive index of air by refractive index of water, which is equal to mu1 by mu2. So what is tan I from this triangle? So this is I is included here from this triangle, that is ABO, from the triangle ABO. This is I, this is 90 degree, this is I, this is 90 degree. Tan is equal to opposite side by base, opposite side by base, that is tan of I is equal to AB by AO. And from this triangle, having the angle R, that is ABI, this is R, and this is 90 degree. Tan of R is equal to AB by AI. In that case, we can write tan I by tan R. Tan I by tan R can be written as tan I by tan R can be written as AB by AO divided by AB by AI. This is tan I is equal to AB by AO, tan R is equal to AB by AI, which is equal to refractive index of air, refractive index of water is equal to refractive index of first medium divided refractive index of second medium. So cancelling this one, AI by AO is equal to refractive index of first medium into refractive index of second medium is equal to refractive index of first medium with respect to second medium, that is air with water. This can be written as 1 by refractive to 1 by using the principle of reversibility. So A is equal to A already given, it is the real depth of the A is equal to AO is equal to real depth of the object. So A is equal to apparent depth. Apparent depth is given by H dash and by H. So we can write this equation by this equation. So with this help, we can write mu12 1 by mu2 by mu1. So which is equal to 1 by mu2. Mu2 is equal to refractive index of this medium, which is nothing but refractive index of water, which we can call it as mu. So which is equal to 1 by 1 divided by mu1. So mu2 is equal to refractive index of water by refractive index of air is equal to 1 by refractive index of air by 1 by refractive index of air by refractive index of water is equal to 1 by mu. So refractive index of water is equal to mu. N to H, therefore H dash by H is equal to 1 by mu, or we can say apparent height is equal to H by mu. Apparent height is equal to H by mu. This is one expression. So we can say the apparent expression, the expression for apparent height is equal to H dash the height of apparent depth is equal to real depth divided by refractive index of the second medium. First equation, already we see tan I from this equation, tan I by tan R is equal to AI by AO, which is equal to height of the depth of the apparent depth divided by actual depth, which is equal to refractive index of the first medium and refractive index of the second medium. That is refractive h dash by h is equal to, this will go up, refractive index of the first medium, that is here, divided by refractive index of the second medium, is equal to refractive index of air by refractive index of water. First expression, the height of the apparent depth of the object is given by this expression, h dash is equal to h by mu. Means we can see this is h dash, which is equal to h by refractive index, which is equal to h dash is equal to real depth divided by refractive index, or we can say h dash refractive index is equal to real height, real depth by apparent depth. So this is also another expression. Now from here we can make another expression. See which medium will be taken. Suppose this medium can be denser, this medium can be rarer, this medium can be rarer, this medium can be denser. So from this relation, mu1 by mu2 is equal to h dash by h. So this is the object from when seen by the eye, the rays starting from here. So from where? Because when the rays coming from the object strikes the eye, then only the eye can see this object. That's why from where the ray starts. The ray starts from here. It means from where the ray starts, that will be treated as the second medium, and where it is emerging, where it is coming out, from here it comes out in the second, in this medium. This medium will be taken as refractive index of in this medium the refractive index will be taken as refractive index 1. So this is equal to refractive index of air, refractive in the waters. Therefore mu2 is equal to mu w, mu1 is equal to mu a. Suppose if it is kept, the object is kept in the rarer medium, it means the rays are going from the object to the eye, then only eyes can see it. So this rarer medium, that is rarer medium, will be kept as a refractive index 2. Where the light is emerging out, that will be kept as mu2, that is mu2, and that will be the following one, where the rays are emerging out to the second medium, that will be kept as the refractive index of the first medium. So this can be written like this: mu2 by mu1 is equal to mu2 by mu1 is equal to h by h dash, or mu2 by real depth is equal to mu1 by apparent depth. This is also another equation. So we come to 4 types of equation. That is, so that can be written it here. All the equations can be written. The apparent depth is equal to apparent depth is equal to real depth divided by refractive index of the medium. Mu2 by h is equal to mu1 by h dash. We can take where mu2 is the refractive index of the second medium, that is water here, denser medium. Mu1 is the refractive index of air, which is h is equal to real depth. H is equal to real depth of the object raised h dash is equal to apparent depth. And another way also it can be written as refractive index of second medium by real depth is equal to refractive index of first medium by apparent depth. So these are the equations. Now normal shift. What is normal shift? The normal shift, we can see how much the object is raised. The AO is equal to real depth, AI is equal to apparent depth, and IO is the height through which the object seems to be raised. IO is equal to normal shift. Normal shift means normally how much the object is shifted upward normally, that is normally along the redirection. So IO, so we can say IO is equal to normal shift. So IO is equal to AO minus AI. IO is IO is equal to AO by AI. So AO is equal to H minus H dash is equal to H minus H by refractive index. So when we take H 1 by mu, this is the lateral normal shift. So this is the normal shift. Now let's see, we can come to the conclusion that the apparent depth H dash is always less than the real depth. That is apparent depth less than real depth. So C for water refracting index is equal to 4 by 3. For glass, the refractive index is equal to 3 by 2. So for this, if the water is kept as the second medium, what is its apparent depth? Apparent depth for water medium is equal to real depth divided by refractive index of water. So H dash is equal to H divided by 4 by 3. Therefore H dash is equal to 3/4 of the real depth. It means the apparent depth is equal to 3/4 of the real depth. For water, for glass, apparent depth is equal to H by refractive index of glass, which is equal to H divided by 3 by 2, which is equal to 2 by 3 of H. It means the apparent depth is equal to 2/3 of the real depth. That it proves that apparent depth is always less than the real depth. And the equation, this is the equation, the height of apparent depth is equal to real depth divided by refraction index of the medium.